Welcome, physics people. It's the end of the fall semester, what a semester it was, and I have time to go over my final exam. So, I'm going to do some of my final exam questions, and I'm going to go over the solutions and the end. So let me just say also for my final exam, I don't try to make super difficult questions. So if these you think, oh, that wasn't too challenging, that's fine. I mean, it's a final exam, so you don't really have as much time to do things as you normally would. So let's just get started. And this first question, I said what it was just for you. I wouldn't tell the students what this was, but this is a physics final. This is for my calculus-based physics class, and this is a question about position, velocity, and average velocity. So it says a bird has a position of 1.2, negative 0.5, 2.1. So I'm just going to write down things as I see them. So let me just, we have the idea here of a bird moving along some place. And so here's the first position, R1. So I'm going to write R1 equals 1.2, negative 0.5, 2.1 meters. And this is the way I write vectors. I took this from matter and interactions. This is the x, y, and z coordinate component of the vector. And it's just a shorter way to do things. And I cut out the question so you wouldn't see my other solution. And this is at a time of t1 of 11.1 seconds. Later at a time of t2 equals 15.5 seconds, the bird is at a position of r2 equals 2.9, 0.6, 4.8 meters. Question: what is the average velocity of the bird? V average vector equals question mark. Vector. It's a vector question. Get it? That's a little physics joke there for you. Okay. If the bird maintains this average velocity, what will be the position at a third time t3 equals 17.3 seconds? I want to know what r3 is. Vector. Okay. Let's get to work. This really isn't that hard of a question. It just depends on the definition of average velocity. So average velocity is defined as a vector as the change in position over the change in time. And so I have two positions. This is just going to be r2 minus r1 over t2 minus t1. Now, how do you subtract vectors? Well, if I want to do r2 minus r1, I'll write it out, and then I'll do it with a calculator in just a second. It would be, the nice thing about writing these in terms of components is to find the x component of r2 minus r1. I take the x component of r2 minus the x component of r1. So this is going to be 2.9 minus 1.2 for the x coordinate. For the y coordinate, it's going to be 0.6 minus negative 0.5. I don't need that. And then I have the z components, 4.8 minus 2.1. And that's in meters. And then the time, you can just take the difference in time. So once you do that, now how do you divide a vector by a scalar? Let's just say t2 minus t1. I can do that in my head. It's going to be, let's see, I'll write it up here. t2 minus t1 is going to be equal to 15.5 minus 11.1, and that's 4.4. Is that right? 4.4. So I'll just have to divide each of these terms to get the average velocity. Let's say, actually, no. Well, I'm gonna want to write it. Yeah, let's do it over here. Over 4.1, I divide each term by 4.1, 4.1, 4.1, and that will give me my average velocity as a vector, which I'm going to do that on the computer. Now let's go to the second part, and then we'll do it all the computation at once. Where's it going to be at t3? So again, I can use the definition. Let's just switch to a new piece of paper. I can use the definition of average velocity. V average equals delta r over delta t. Now I want to say delta r is going to be r3 minus r1 over t3 minus t1. I can use any 2 points I want. If the average velocity is average, if it has that same average velocity, then that's true. So you could say that, and that's fine. So now I want to solve for R3. So I'm going to multiply both sides of the equation by T3 times minus T1, and I get R3 minus R1 equals v average, the vector, times t3 minus t1. Now I can add r1 to both sides. I get r3 equals r1 plus v average times t3 minus t1. So you should have a vector for this, and I just need to multiply this by the difference in time here, which I'm not going to write out because I'm going to do it with my calculator, and then add it to the vector r1. Now you could also do this as r3 minus r2 over t3 minus t2, and it will give you the exact same answer. Okay, so now I'm going to do this. I'm going to do these calculations, and I normally would use a calculator like this. I would use maybe my Hewlett-Packard RPN calculator, but the best calculator, of course, as we know, is Python, and I let students use Python on my exams, so let's just switch over here to Python. Okay, so this is trinket.io. It's a website where you don't have to install Python. I've already said make a new trinket of type glowscript. And now it gives you this option between blocks and Python. Let's do Python. Oh, I covered up my questions. I can't see what my numbers are. Okay, so let's just start entering in everything that I already know. Let's say this. This is amazing. This is amazing. R1 equals vector 1.2, negative 0.5, 2.1. I'm just going to print that just to show you. It can deal with vectors in Python. Yes, that is indeed awesome. Okay, you don't put the units in there because we're dealing with these as numbers. T1 equals 11.1, T2 equals 15.5, R2 equals vector 2.9, 0.6, 4.8. Yay. Okay, now let's go ahead and calculate the average velocity. V average equals R2 minus R1 divided by T2 minus T1. This is what's so great. Oops. This is what's so great about using VPython as your calculator. I mean, once I enter the numbers in, I just type the equation. That's all I did. And it can deal with these vector operations fine. So now let me print that out. Print V average equals, as a text, comma, V average, comma, meters per second. So I'm going to make it look pretty. So let's run that. And there you go. There's your average velocity. 0.386, 0.25, 0.61 meters per second. I guess I should save this. Phys 221 final question 1. I'll give you the link down below. Okay, now I need to do the other, Now I need to do the other part. T3 equals 17.3. Now again, I can just type in my equation and I can say R3 equals R1 plus, I am having trouble typing, V average times T3 minus T1. That's all I have to do. Print R3 equals R3 meters. And there's your final position. Let's just, since it's so easy, let me just show you R3 equals R2 plus V average times T2 minus T1 and print that. And I get T2 R3. Something different. What? R1 T3. Wow. Okay, so I messed up somewhere. R1, R2, V average, R2. That looks good. T3 is 17.3. R3 is R1 plus V average times T3 minus T1. Huh. Why is it giving me a different answer? So R3A. Oh. No? So give it a different name. Wow. It should work. Oh, T2. Aha. It's R3 is equal to T3 minus T2. Okay, that was just I was just going to. I was excited to show you that it's the same thing. I didn't print that. It's good. It's a good little test, right? Same thing. Whew. Wow. Okay. So there you go. That's the first question. I'll do another question soon. Use Python as your calculator or not, whatever makes you happy.